Bismillahirrahmanirrahim. Dear students, this is the Pakistan International School Taif and subject chemistry and grade 12, second year. Lecture number 19, and we are talking about the transition elements and vanadium we already started. So in the previous lecture, I told you about the change in oxidation number of vanadium positive 4 to positive 5 to positive 4. Positive 5 to positive 4. Now here the point C. Point number C is, this is the page number 74. Page number 74, reduction from positive 4 to positive 2. Reduction from positive 4 to positive 2. So yesterday I told you the reduction from positive 5 to positive 4, we are talking about vanadium. So dear students, the color changes just continue. The reason for the inverted comma, see here we will just study here also. For the only simplification, simplicity, simplification. That's why we give the inverted commas, no other reason. The exact nature of complex ion will be depend upon which acid you use in reduction process. It means that nature of the acid is very important for the reduction. So students, see this one. The vanadium 5 oxide means vanadium pentoxide, which is used as a catalyst in the contact process. Already we done this one. So here in the first floss, you are seeing that there is a blue color and oxidation state of vanadium is positive 4, and don't oxygen because of we are talking about reduction. Reduction means decrease in oxidation number, so there should be no oxygen. That's why it is closed by the water. It's closed. So now in the first case, oxidation state is plus 4 and VO plus 2. Oxygen is minus 2 and vanadium is positive 4. Total oxidation number is plus 2. Oxidation state 4. So this is the vanadium oxide, negative 2 on oxygen. Vanadium has a positive 4 and total oxidation number on VO is a positive 2. So this is one case, the color is blue. Intermediate, I told you the color is in between. This violet, somehow violet color and blue color. There is an intermediate which is a oxidation state. Oxidation state is plus 3, which is an intermediate one. In between 4 and 5. So the complex vanadium, water, and there are 6 like this one. An oxidation state is positive 3. So because of water is a neutral and there is a no oxidation state on water, so this positive 3 is only for the vanadium. So there this shows vanadium positive 3 in oxidation state. So this is the transition state, intermediate state is given here. Now in the last number 3, so the oxidation state is plus 2. Oxidation state is plus 2. So vanadium, there is a water in the small bracket and 6. This is the square bracket Write. If not written, write down. And this is the water, which is a zero oxidation state, neutral, and positive 2 after the bracket is for the vanadium. So this is for the vanadium. And this color is somehow violet color. According to your book, the color is shown in violet, and in the previous section I told you the square bracket is only for the simplification, no other, like this one. These inverted commas and square brackets. So dear students, this is a change of oxidation state, vanadium positive 4 passing through intermediate and finalized to positive 2 oxidation state of the vanadium. And it is very important, it's written here that the nature of the color of the complex depends upon the nature of the acid you added. It is written here. The exact nature of a complex ion will depend on which acid you use in the reduction process. So if you see the B section which we completed yesterday, and here we done hydrochloric acid with zinc. So hydrogen, nascent hydrogen is going to be produced and which used as reduction process. So here we use hydrogen chloride. So students, this is about the change of oxidation state. There is another one very important, so I am going to remove this. Already I told you that vanadium pentoxide, vanadium has a positive 5 oxidation state, oxygen has a negative 2, which is used as a catalyst in contact process for the preparation of sulfuric acid, and the percentage purity of sulfuric acid is about 100%. Contact process, we use catalyst. Catalyst is a substance which increase the speed of the chemical reaction. So in the first chemical reaction you are seeing sulfur dioxide gas, half oxygen gas, and catalyst is a vanadium pentoxide, oxidation number shown positive 5, and this is going to be changed into sulfur trioxide gas. Sulfur dioxide gas changes into sulfur trioxide gas. So we use vanadium pentoxide as a catalyst. The reason because of sulfuric acid is called king of the chemicals. So 100% sulfur trioxide should be consumed during the chemical reaction, and there should be a complete conversion of sulfur dioxide to sulfur trioxide. That's why we have to be careful about, very careful about this process. In the previous books there was, but nowadays there's no topic in your books. Okay. How the reaction works? How the reaction works? This is a good example of the ability of transition metals and then compounds to act as a catalyst during the chemical reaction, during the different process, and ability to change the oxidation state. Variation in oxidation states. Variation in oxidation states, change in oxidation state. How they change their oxidation states during the chemical reaction. Sulfur dioxide is oxidized to form sulfur trioxide in the presence of vanadium thioxide as a catalyst, and the oxidation state of sulfur vanadium is here positive 5. So when the sulfur dioxide changes into sulfur trioxide, this is a sulfur dioxide and we use vanadium pentoxide. The oxidation number of vanadium is positive 5 and this is going to be converted sulfur trioxide gas. Now this is not a permanent change. Temporarily the vanadium pentoxide changes into vanadium tetroxide. Oxygen is negative 2, negative 2 multiplied by 4, negative 8, the vanadium should be positive 4. So here the oxidation number of vanadium is going to be changed, reduced. Positive 5 changes into positive 4 for the time being. Because catalyst does not involve chemically, does not change chemically during the chemical reaction. When the chemical reaction ends, when it completes, so in the loss we must recover same. That's why in this process, this vanadium 4 oxide, oxidation number of vanadium is a 4, so it is going to be reoxidized. There the reoxidation and changes into its original vanadium positive 5 oxidation state. So it must be recovered same as we added here. To be same. State may be different. Before it was crystalline, maybe the amorphous powder form and maybe solid you form in the liquid, but chemically it should be same. Sulfur dioxide oxidizes sulfur trioxide and vanadium trioxide. In the process, vanadium oxide 5 reduces to 4 vanadium oxide. So although the catalyst has been temporarily changed, I told you, no permanent change takes place in the process during the chemical reaction. At the end, it is chemically same as it started. When we start here, it must be same after the completion of chemical reaction. So this is the function of transition metal compounds as a catalyst in different processes. So dear students, we complete this topic here and there are some questions here. If you see the box, page number 75, do you know reduction of vanadium? Vanadium pentoxide dissolved in hydrogen chloride gas give the salts like vanadium oxidichloride VOCl2 and VCl5. So if I'm going to write these chemical reactions, Number one chemical reaction is vanadium pentoxide V2O5 minus 2 plus 5 vanadium, and he say when we add hydrochloric acid, so what you will get vanadium oxidichloride 3 moles of water, and the chlorine is going to be oxidized because chlorine has -1. There is oxidation. And in this case, chlorine is a -1 multiplied by 2, -2, and this oxygen is also -2, so this should be +4. So this is a reduction of vanadium. Vanadium is going to be reduced and the chlorine is going to be oxidized. The liberation of chlorine gas indicates that vanadium pentoxide is going to be reduced and chlorine is going to be oxidized written here. So this HCl is going to be used as a reducing agent, and vanadium pentoxide acts as an oxidizing agent because it oxidizes the chlorine. So vanadium pentoxide itself reduces and oxidizes the chlorine. This is reaction number 1. Now in the reaction number 2, you are seeing that vanadium pentoxide same plus reduction of chlorine indicates vanadium oxidized, can be used to oxidizing agent. React also HCl in this chemical reactions. Again, we say in this manner can be reaction taking place. So you will get a VCl5 and 2H2O. But the students here, there is no oxidation and reduction. No oxidation reduction. Because vanadium is positive 5 and vanadium is also positive 5. Chlorine is negative 1. So there is no oxidation reduction taking place here. So number 2 chemical reaction, this is a part of this one. Number 2 chemical reaction is vanadium pentoxide when reacts with nitric acid. This is the nitric acid and you will get HVO3 plus N2O5. This is called meta-vanadic acid. This is called meta-vanadic acid. The oxidation state of vanadium is here oxygen negative 2 multiplied by 3 negative 6 positive 1 and positive 5, and here is also positive. It means that there is no change in oxidation number. Nitrogen is positive 5 here and negative 2 multiplied negative is also positive 5. There is no change in oxidation number. Only you will get the acid which is called a meta-vanadic acid in this chemical reaction. This is these chemical reactions are given extra in your book. Now, quick quizzes. Give source of vanadium 5 in oxidation state. So source is conversion of ammonium pentane, page number 74, to vanadium pentoxide. This is a source where we prepare vanadium 5 oxide from ammonium pentane. Page number 74, number 2 topic is the answer. How reoxidation of lower oxidation state of vanadium is prevented, means control conditions. This is used as a catalyst in the preparation of sulfuric acid. And this process again, he say how sulfur dioxide changes into sulfur trioxide and how catalyst is going to be used up. So students, this is about the vanadium. You know, organic chemistry, inorganic chemistry typically difficult because of mechanism is not involved and complicated chemical reactions are given, and one chemical reaction is different from other. So you must practice, must remember these chemical reactions by writing. So students, now there is another very important metal. We discussed very important metal which is commonly used in our daily life, that is called chromium. This is another very important transition metals we are going to discuss, and this is a very, very important again. The first topic is again interconversion. Interconversion. One oxidation state to other oxidation state. So number 1 is interconversion of various oxidation states of chromium. This is number one. So how we change one oxidation state to another oxidation state as we done for the vanadium. Number two, chromate 6 Cr2O7 we call dichromate ion. Chromate 6 dichromate positive 2. This is the dichromate. And there is another one, chromate. Or this is a chromate. Oxidation number same. Oxidation number of the chromium in both same. This is called dichromate 6 and this is the chromate 6. Oxidation number of chromium is both. This dichromate mostly these colors are orange color, pink orange color, and this chromate is yellow. The compounds of dichromate mostly they are orange color and the chromate are yellow color. Number two. Number three is use of dichromate means this use of Cr2O7 negative 2 as an oxidizing agent. Oxidizing agent in the process of titration. You may heard this name titration. There are many types of titrations, acid-base titration, oxidation, reduction, redox titration, iodomated titrations. There are many types. So this is the oxidation and reduction titration because oxidizing agent is used here. So these are the three topics we discuss in the chromium. So the oxidation of chromium 3 to chromium 6 first. I mean how chromium positive 3 oxidizes to give chromium positive 6. So an excess of sodium hydroxide NOH. Sodium hydroxide excess. In excess of sodium hydroxide is added to the solution the hexa aqua chromium 3. Hexa aqua. You must know the nomenclature. Hexa aqua chromium 3 is going to be changed by addition of sodium hydroxide. Temporarily you are getting the trihydroxo aqua chromium. This is the chromium and this is the water and 3 and the trihydroxo like this one. This is the compound, this is not an ion, there is no oxidation number, this is a neutral hydroxyl group contain negative 1 multiplied by negative 3 and chromium 3. So cancel, this is the compound here. So this color may be the slightly turbidity means gelatinous is going to be formed light green color. Then in the last hexa aqua chromium 3 positive and which is going to be blackish bluish color is going to be formed. So when you are going to put the hexa aqua chromium 3 the hydrogen peroxide solution upon heating the yellow color of chromate is going to be formed. So students, this is the change of the color and oxidation state. So final oxidation state is like this. I told you this is the chromium and the hydroxyl group is going to be involved here. So there should be -3 because hydroxyl group contain -1 -6. So hexahydroxychromate 3. Hexahydroxychromate 3 negative charge is here due to the negative hydroxyl ion. Positive charge is here because water is neutral. So this water ligand 6 and here hydroxyl are ligand 6. So dear students, in the hexahydroxychromate 3, when we add the hydrogen peroxide, this color is going to be changed to yellow. So this color is going to be changed to yellow color from the orange to yellow color. So students, here we are going to be end here. So inshallah, next we will give the we will explain different examples of this chromium and the chemistry of chromium and dichromate ions. These are the very important and also complicated structures. Must revise at your home. Thank you very much.